genius. The greatest thing about him, probably, is how he turned out to be this amazing mathematician, despite having little or no formal outside exposure to advanced mathematics. He was a self-taught genius from a very humble origins, completely disconnected from the world of other excelling mathematicians, and largely worked out of his own, in utter isolation, and often in poverty. Ramanujan possessed an incredibly amazing intuition of numbers, fractions, and infinite series, possibly like no other mathematician ever did. He churned out a huge number of significant and complex results, largely based on intuition, mingled with argument and induction, and some sort of innate insight that only seemed to be possessed, often without formal proofs and coherent accounts. Ramanujan attended the local grammar school and high school and early on demonstrated an affinity for mathematics. When at age 15, he obtained an out-of-date book called A Synopsis of Elementary Results in Pure and Applied Mathematics. Ramanujan set about feverishly and obsessively studying its thousands of theorems before moving on to formulate many of his own. At the end of high school, the strength of his schoolwork was such that he obtained a scholarship to the government college in Kumbakonam. But Ramanujan's greatest asset proved also to be his Achilles heel. He lost his scholarship to both the government college and later at the University of Madras, because his devotion to math caused him to let his other courses fall by wayside. With a little in a way of prospects, in 1999 he sought government unemployment benefits. Yet, despite these setbacks, Ramanujan continued to make strides in his mathematical work, and in 1911 published a 17-page paper on Bernoulli numbers in the Journal of Indian Mathematical Society. Seeking the help of members of the society, in 1912, Ramanujan was able to secure a low-level post as a shipping clerk with the Madras Port Trust, where he was able to make a living while building a reputation for himself as a gifted mathematician. Around this time, Ramanujan had become aware of the work of British mathematician G.H. Hardy, who himself had been something of a young genius, with whom he began a correspondence in 1913 and shared some of his work. After initially thinking his letters a hoax, Hardy became convinced of Ramanujan's brilliance and was able to secure him both a research scholarship at University of Madras as well as a grant from Cambridge. The following year, Hardy convinced Ramanujan to come study with him at Cambridge. During their subsequent 5-year mentorship, Hardy provided the formal framework in which Ramanujan's innate grasp of numbers could thrive, with Ramanujan publishing upwards of 20 papers on his own and more in collaboration with Hardy. Ramanujan was awarded a Bachelor of Sciences for Research from Cambridge in 1916 and in 1918 became a member of the Royal Society of London. Ramanujan made many momentous contributions to mathematics, especially number theory. Much of his work was done jointly with his benefactor and mentor G.H. Hardy. Together, they began the powerful circle method. The circle method has played a major role in subsequent developments in analytic number theory. Ramanujan also discovered and proved that 5 always divides b bracket 5n plus 4. 7 always divides b bracket 7 9 plus 5. And 11 always divides b bracket 11 9 plus 6. This discovery led to extensive advances in the theorem of modular forms. Of Ramanujan's published papers, 37 in total, Professor Bruce C. Burnt reveals that a huge portion of his work was left behind in 3 notebooks and a lost notebook. These notebooks contain approximately 4,000 claims. Most of these claims have now been proved, and like his published work, continue to inspire modern-day mathematics. A biography of Ramanujan titled The Man Who Knew Infinity was published in 1991, and a movie of the same name starring Dev Patel as a Ramanujan and Jeremy Irons as Hardy premiered in September 2015 at the Toronto Film Festival. Years of hard work, a growing sense of isolation, and exposure to the cold, wet English climate soon took their toll on Ramanujan, and in 1917 he contracted tuberculosis. After a brief period of recovery, his health worsened, and in 1990 he returned to India. Srinivasa Ramanujan died of his illness on 26 April 1920 at the age of 32, and even on his deathbed had been consumed by math, writing down a group of theorems that he said had come to him in a dream. These and many of his earlier theorems are so complex that the full scope of Ramanujan's legacy has yet to be completely revealed, and his work remains the focus of much mathematical research. His collected papers were published by Cambridge University Press in 1927.
Hello everybody, myself Nithin. I'm here today to speak on the topic Math is the hidden secret to understand the world. Knowing math is like wearing a pair of X-ray specs that can reveal hidden structures underneath the messy and chaotic surface of the world. With the tools of math in hand, you can understand the world in a deeper, sounder and more meaningful way. But how? How is math a hidden secret to understand the world? That's indeed an excellent question. Now, through the lens of some mathematical ideas, let's examine this. Everyone needs math in their day-to-day life. Even insects use math in their everyday life for existence. Snails make their shells, spiders design their webs, and bees build hexagonal combs. There are countless examples of mathematical patterns in nature's fabric. When it comes to human beings, while preparing food, we always measure the different ingredients so as to cook the desired quantity only. This is possible only because of math. So you can say that our day begins with the concept of math. Shopping. When going for shopping, we prepare a list of items we require and calculate the amount of money needed for it. So in case of shopping too, you are surrounded by the world of math. A study of geometry can explain the science behind architecture throughout the world. Statistics and probability can estimate death tolls from earthquakes, conflicts, and other calamities around the world. So math is a powerful tool for global understanding and communication. Now it's time for me to explain the very scientific core concepts of the world through the lens of math. In 1687, Newton believed that the universe could be understood as a mathematical object. Leibniz, another great scientist, discovered another link between math and nature when he first considered the idea of fractals. German Swiss American physicist Albert Einstein's theories of special and general relativity had shown that nature obeys the laws of math. Oh damn, this is more interesting, right? Hey, this perfectly outlines that math is definitely the hidden secret to understand the world. Well, math gives us hope that every problem has a solution, isn't it? If you examine math, every question, every problem has its own solution. Likewise, whenever you face any problem or difficulties, then just think of math. Because math says that there is a solution for your problem also. Finally, the power of math is that it is the hidden secret to understand the world. Galileo Galilei once said, if I were again beginning my studies, then I would follow the advice of Plato and start with math. I think you can understand the inner meanings and the essence of Galileo's words. Thus, it is very obvious that math is definitely the hidden secret to understand the world. Thank you for listening, and just remember, without math, there's nothing we can do. Thank you.
Hi Prathiksha.
Hello DEEPTHI.
Why were you absent yesterday?
He went to my grandma's home.
Okay. You know that our school is going to celebrate Srinivasa Ramanujan birthday.
You mean National Mathematics Day?
Yes, you were right.
Who is Ramanujan?
He is an Indian mathematician who knows infinity.
Can you tell more about him?
Yes, I can. Srinivasa Ramanujan was born on the 22nd of December in the year 1887, Madras Presidency. He was born on Brahmin family. He was also an autodidact. He was a very shy person, and is said that he was very well-mannered man. He was very determined and a dedicated person. He worked very hard, which results in several achievements. He married Srimati Janki, who was a 10-year-old girl on the 14th of July 1909. A girl his mother had selected for him. Ramanujan was the first Indian to be elected to the Royal Society in London.
It is very interesting to know about our math genius.
You know that researchers are still struggling to understand the source of his remarkable genius in mathematics.
Thank you, DEEPTHI, for your kind information.
Welcome.
Bye, we will meet soon.
Bye.
Hello friends, I am AMOTHIKA of grade 4. I would like to share a fascinating event in a school at Kumbakonam in the early 20th century. The arithmetic class was in progress. The teacher was solving questions on division. On the blackboard were drawn 3 bananas. We have 3 bananas, the teacher said, and we have 3 boys. Can you tell me how many each will get? A smart boy in the front row replied, each will get 1. Right, the teacher said. Now similarly, if 1,000 bananas are distributed among 1,000 boys, each will get 1. Isn't it that so? While the teacher was explaining, a boy sitting in one corner raised his hand and stood up. The teacher stopped and waiting for the boy to speak. Sir, the boy asked, if no banana is distributed among no one, will everyone still get 1 banana? There was a roar of laughter in the class. What a silly question to ask. Quite, the teacher said loudly and thumped the desk. There is nothing to laugh at. I will just explain what he means to say. For division of bananas, we divided 3 by 3, saying that each boy will get 1 banana. Similarly, we divided 1,000 by 1,000 to get 1. What he is asking is that if 0 banana is divided among 0, will each one get 1? The answer is no. Mathematically, each will get an infinite number of bananas. Everyone laughed again. What they could not understand was why the teacher laterly complimented the boy who asked the silly question. The boy had asked a question that had taken mathematicians several centuries to answer. Some mathematicians claimed that 0 divided by 0 was 0. Others claimed it to be unity. It was the Indian mathematician Bhaskara who proved that it is infinity. The boy who asked the stimulating question was Srinivasa Ramanujan. Throughout his life, whether his native Kumbakonam or Cambridge, he was always ahead of his mathematics teachers. Thank you for giving this opportunity to share about who had born in Erode, like us, made a history in his life with mathematics.
A warm greetings to one and all. This is KIRUTHIK of grade 9B from Bannari Public School. I'm here to share my insights on this great day, Ramanujan Day. Today, I'm standing here to tell you all about you great mathematician Ramanujan. Firstly, I would like to say thanks to our respected secretary sir, our beloved principal ma'am and vice principal ma'am, and our lovable teachers who gave a golden opportunity to express my views. I'm so glad to be over here. Srinivasa Ramanujan is the most remarkable mathematician in India. The story of his life is dramatic and somewhat larger than life. Let's highlight some of the points of Ramanujan's life which are incredibly inspiring. Ramanujan was slightly self-taught and emerged from extreme poverty. He cultivated his love for mathematics single-handedly and in total isolation. At the age of 12, he borrowed from a friend a copy of Lonely's book on a plane trigonometry, which was published by Cambridge University Press in 1894. This book and a synopsis of elementary results in pure and applied mathematics gave a big dimension of Ramanujan's life and brought him to the door of 20th century mathematics. Within his limited period, he completed 3,900 results which are mostly on identities and equations. The last of the 3 of Ramanujan's speculations created a sensation in 20th century mathematics. The most celebrated discoveries of him were the infinite series of pi. As per the report, Ramanujan liked to write his ideas in a notebook in green ink. One of his notebooks was known as the Lost Notebook. It was discovered in the Trinity College library by mathematician George Andrews in 1976. Later, it was later published as a book. Ramanujan's birth anniversary, which is on December 22, is celebrated as a National Mathematics Day every year. He is a symbol for aspiring young Indian students to break their bonds of intellectual confinement and perhaps sort the way that Ramanujan did. Ramanujan embodies that marvelous miracle of the human mind to frame concepts and use formulas and symbols as tools of thought. It recognizes as a powerful tool deeper into the mysteries of the universe and the mysteries of one's own being. As long as the spirit of inquiry and inquisitive minds are alive, Ramanujan's legacy will pass from one generation to the next. APEX salutes him. A great salute to Ramanujan from Bannari Public School. Yes, our teachers are also expecting the same contribution like Ramanujan contribution from us. Yeah, on behalf of BAPS, I'm going to take the oath. We, the students of BAPS, will give the expected vision in the future development. Thank you.
Respected principal and teachers, good evening everybody. I am TM RAGAVARSHAN. I am going to short speech of Srinivasa Ramanujan. Srinivasa Ramanujan was a great mathematician. This great mathematician was born on December 22 at Erode, Tamil Nadu. His birthday is being celebrated as National Mathematics Day. He lived just for 32 years, but during the short lifespan, he introduced many useful theorems, number theories, infinity series, and solved the problems in mathematics. He had no formal training in mathematics. He complied over 3,500 identities and equations. Nowadays, Ramanujan's formula are being used. Srinivasa Ramanujan's victory is very, very big. Thank you everybody. Jai Hind. Hi everybody, I am KM RAGAVARSHAN. Place value rolling card. 43 roll it. Answer. 3 ones and 4 tens. 37 roll it. Answer. 7 ones and 3 tens. 45 roll it. 5 ones and 4 tens. 72 roll it. Answer. 2 ones and 7 tens. 69 roll it. 9 ones and 6 tens. 53 roll it. 3 ones and 5 tens. 95 roll it. 5 ones and 9 tens. 23 roll it. Answer. 3 ones and 2 tens. 57 roll it. Answer. 7 ones and 5 tens. 67 roll it. Answer. 7 ones and 6 tens. 33 roll it. 3 ones and 3 tens. 53 roll it. 3 ones and 5 tens. 95 roll it. 5 ones and 9 tens. 23 roll it. Answer. 3 ones and 2 tens. 57 roll it. Answer. 7 ones and 5 tens. 67 roll it. Answer. 7 ones and 6 tens. 33 roll it. 3 ones and 3 tens. 47 roll it. Answer. 7 ones and 4 tens. 58 roll it. 8 ones and 5 tens. 62 roll it. 2 ones and 6 tens. 82 roll it. 2 ones and 8 tens. 93 roll it. 3 ones and 9 tens. 25 roll it. 5 ones and 2 tens. 32 roll it. 2 ones and 3 tens. 72 roll it. 2 ones and 7 tens. 48 roll it. 8 ones and 4 tens. 51 roll it. 1 ones and 5 tens. 64 roll it. 4 ones and 6 tens. 35 roll it. 5 ones and 3 tens. 27 roll it. Answer. 7 ones and 2 tens. Thank you everybody. Good morning everybody. I am TM RAGAVARSHAN. This is the adding box. I put 3 stones. 1, 2, 3. And I put 2 stones. 1, 2. I take. One, 2, 3, 4, 5. Answer is 5. So 3 plus 2 equal to 5. I will put 2 stones. 1, 2. Again I will put 2 stones. 1, 2. I take. One, 2, 3, 4. Answer is 4. So 2 plus 2 equal to 4. I will take 1 stone. 1. And I will put 2 stones. 1, 2. Answer is 1, 2, 3. Answer is 3. So 1 plus 2 equal to 3. I will take 4 stones. 1, 2, 3, 4. And I will put again 4 stones. 1, 2, 3, 4. 1, 2, 3, 4. I take. One, 2, 3, 4, 5, 6, 7, 8. Answer is 8. So 4 plus 4 equal to 8. Thank you ma'am. Bye ma'am. Good morning ma'am.
8 plus 9,
17,
10 plus 10,
20,
9 plus 10,
19,
2 plus 8,
10,
40 plus 40,
80,
7 6 are,
42,
9 8s are,
72,
6 5s are,
30,
3 6 are,
18,
2 5s are,
10,
25 minus 10,
15,
10 minus 9,
1,
8 minus 5.
3,
How many edges are in the cube?
8,
How many flat faces are in the cube?
6. Thank you.
Hi from Dhanush. The pleasant morning to everyone. Our school has planned to make a mathematical project on Ramanujan's birthday, and this is my project. This is a small experiment about a circle and its plot. The materials required to do this project are a piece of cardboard to cover a newspaper, to decorate some wires and lights, to connect it to some batteries, to make it colorful, some colors. I have finished my project and I am going to explain about it. Circle. This is circle. This is circle. This is chord. This is diameter. This is radius. This is O, the center of the circle. Thank you and have a nice day.
A very warm greetings to one and all. Myself, KIRUTHIK, grade 9 from Bannari Public School. I'm very proud to introduce myself in front of you all. So today, let's see interesting topic, day of any day. Do you have any guess? Come on friends, let's have fun. Yes, my dear friends, this is my project. Any idea? Okay, come on, let's have an interesting fun. Yes, day of any date. This project represents century code, month code and day code, and also helps us to find the day of any date. Yeah, now let's find the day of Independence Day. Yeah friends, now let's take an example of Independence Day. 15/8/1947. This is Independence Day. So, here, as I told already, century code, month code and day code represents this day of any day. So now, let us keep this 15 as such here. And 8 is a month, so we have month code for that. So 1, 2, 3, 4, 5, 6, 7, 8. So here 3 represents the 8. So let's write, substitute a value of 3. And next, 19. So we all know that 19 represents the century code. So what is given here? 1900 to 1999 is 0. So let's substitute the value 0. And next, it is given 47. Let's as it right, there is no change. So 47. So now we have to find the leap year for that. So now let's find. Yeah, now let's divide 47 divided by 4. Yeah friends, why should we divide by 4? Because it is leap year. So now, let's divide. So, we get the quotient as 11 and the remainder as 3. So, for a leap year, we have to consider the quotient. So, now let's substitute the quotient here, which is 11. So now, my friends, let's add all these numbers to get a total. So 15 plus 3, 18, 18 plus 47, 65, and 65 plus 11, it is 76. So now we have to divide it by 7. Now let's see by dividing 7. Right friends, now let's divide 76 divided by 7. So 7, 1, 0, 6. And we get the remainder 6 and the quotient 1. So when we divide, after the total, we have to consider the remainder. So why are we dividing it by 7? So we know there are 7 days in a week. So that we are dividing it by 7. So now let's substitute the value. So we are getting the remainder 6. What this remainder represents? Yeah, you're right, your friends. It represents the day, that is Friday. So as I told, we get a remainder 6. So yeah, friends. So here there is a number 6 which denotes the day Friday. So now we have found the day of Independence Day. So some conditions are required. So this is a normal method and some conditions are required. So for example, if a year is a leap year and the month is Jan or Feb, we have to subtract 1 from the total, minus 1 from the total. So this is a condition when a year is leap year or the month is Jan or February. So I think it is an easiest way and it is a wonderful method to find the day of anything. Thank you. Yes, my dear friends, I hope you all have enjoyed this project. Now, this is your turn to find your birthday day and your family members too. Thank you, teachers and my dear friends. Once again, thank you so much.
Hello everybody, this is Neha of grade 9B here to discuss few Venn diagrams. First question, which of the following represents the relationship between sun, moon and molecules? We know that all the matter in the universe are made up of molecules. So even we can say sun and moon are made up of molecules. The first important thing is draw the diagram according to your understandability so that it will be easy to find the answer. If you see here the molecules and sun and moon is made up of molecules. So this is the thing which coincide exactly with this and right answer. The next question, which of the following diagram represents the correct relations between year, week and days? We can say every year is having month and every month is having week and every week is having days. So in our question they doesn't give month, so leave it. The given thing is year, week and days. According to this, draw the diagram. There is a year which is comprising the week and the weeks are exactly comprising days, coinciding with this right answer. It is the right answer. The next question, represent the relationship between human being, teachers and graduates. We can say in this world all the teachers and graduates are human being, right? So human being, so we can say all the graduates are not teachers and all the teachers may not be graduates. So we will see there are graduates and few of them are teachers. So if you see from this side, the teachers among whom few are graduates. So this is the right answer. The next question, which of the following correctly represents the relationship between judge, criminal and thief? So judge, he is neither a criminal nor a thief, right? So in our real day life, so we'll keep judge aside. So criminals and thieves. So if you see criminals and thief, all the thieves are exactly criminals, right? But not all the criminals are thieves. They might be doing some murder like that, etc. So here if you see that judge is here, and if you see there are thief and all the thieves are criminals, right? So this is the criminal and all criminals is consisting of thieves also. So this is exactly coinciding with this option. So this is the right answer. So this is our right answer. Then last question. So which of the following diagrams represents the relationship among Delhi, Lucknow and Uttar Pradesh? So we know that. Imagine this is our state. So just imagine it. So here is Uttar Pradesh and it is having a capital Lucknow in it. Our India's capital Delhi is up aside from it. So it's here. If you see Lucknow, zoom it, you can see that, you can see Lucknow, state Uttar Pradesh, which is having Lucknow in it, and there is India's capital Delhi aside it. So this exactly obeys this third option. So thank you.
Good morning. Today I am going to tell about Srinivasa Ramanujan. Srinivasa Ramanujan born December 22, 1887, Erode, India. Died April 26, 1920, Kumbakonam, India. Mathematician who contributes to the theory of numbers include pioneering these discoveries of properties of Petty's function. When he was 15 years old, he obtained a copy of Geography. Showbridge carries syllables of elementary results in pure applied mathematics to wall 1880 to 86. This collection of thousands of theorems, many presented with only the brief proofs and with no material newer than 1860. Around his genius having verified the results of Carey's book, Ramanujan went beyond it, developing his own theorems and ideas in 1903. He secured a scholarship to the University of Madras, but he lost it following year because he neglected all other studies in purpose of mathematics. Ramanujan continued his work without employed and living in the poorest criminals. After marrying in 1909, he began a search of permanent employment and that commutator in an interview with a government official, Ramachandra Rao, impressed by Ramachandra's mathematical powers, so Rao supported his research for a time. But Ramanujan, unwilling to exit a charity, obtained a senior post with the Madras Port Trust. In 1911, Ramanujan published the first of his papers in the Journal of the Indian Mathematical Society. His genius gained recognition, and in 1913 he began a correspondence with a British mathematician, Geoffrey Hardy, that led to a special scholarship from the University of Madras and a grant Trinity College, Cambridge. Overcoming his religious objections, Ramanujan travelled to England in 1914. He very hardy theory and collaborated with him in research. Ramanujan's knowledge, mathematician, most of which he had worked out for himself, was startling. Although he was almost completely unaware of modern developments in mathematics, his mystery and of continued functions was unequivocally by a living mathematician. He worked on the Riemann series, the etheric intelligence, Hebrewic series, the functional quantity of the zeta function, and his own theory and of divisor series. On the other hand, he knowing about doubtfully periodic function, the classified theory of quadratic forms or quantity theorem, and he had only the most remedious idea of what constitutes of mathematical proof. The brilliant many of his theorems on the theory of prime numbers were wrong. In England, Ramanujan made further advances in the preparation of numbers. The numbers of ways that a positive integer can be as the sum of positive integer. Example 4 and can be expressed as 4, 3 plus 1 plus 1, 2 plus 2, 2 plus 1 plus 1 and 1 plus 1 plus 1 plus. These papers were published in English, European journals in 1980 he was dedicated to the Royal Society of India, London. In 1970, Ramanujan had considered contribution, but his condition improved and suited for him to return to India in 1919. He died the following year, generally unknown to the world at large, but recognized by mathematicians as phenomenal genius without a peer since Leon Lurer 1907 to 1983. The Carol Jobry 1804 to 1815. 1. Ramanujan left behind 3 notebooks but a chief 4 pages also called the Lost Notebook, containing many published research and that mathematician continued to welfare long after his death. Thank you.
A very warm good morning to all. I am Abhinaya here today to speak about the mathematics wizard Srinivasa Ramanujan, who is one of the world's greatest mathematicians, and he is known for his great works done in his field. He was born on December 22, 1887 in Erode, and he is known by many contributions made in the theory of numbers. Ramanujan chose to create his own path into mathematics at only the age of 13. He focused on the sum of geometric and arithmetic series. In 1902, Ramanujan created a method for solving quadratic equations, and just 2 years later, he explored Euler's constant and was able to calculate it to 15 decimal places. Just like any random person, Ramanujan had a source of inspiration. He was influenced by a famous book of G.S. Kant, a synopsis of elementary results pure mathematics, which was basically condensation of 5,000 algebraic, calculus, trigonometric and analytical geometric equations of late 19th century. In 1931, he casually wrote to the well-known Cambridge mathematician G.H. Hardy and told him about his work. Hardy was mighty impressed with Ramanujan's work and assisted him in getting a grant from Trinity College, Cambridge. Ramanujan moved abroad and started to work in collaboration with Hardy, but his health started falling. Despite poor health, he remained engrossed in research. In 1920, he moved back to India and left his heavenly abode. Although he is no more, his innovative ideas and visions still serve as a great resource for modern mathematicians. Thank you for listening patiently. Thank you.
Hello everyone, I am Aradhana of class 10 here to present a video on the topic shortcut methods. Now I will explain few methods to use for the tables 2, 3, 6, 7, 8 and 9. First, by using neem leaf, let me explain second table. So 2 1 is 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10 and 2 6 are 12. So we have 12 leaves, so you can continue this. Now next, let us see third table. First write 1 2 3 in the given order. Now add zeros to the first row, 1 to the second row and 2 to the third row and 30 at last. So here we have 10 multiples of 3. So continue this. And add 60. So we can continue this up to 3 into 30. Now by using the same method, let me explain sixth table. So draw a square at the middle and don't consider the center number. So we have 6 1 is 6, 6 2s are 12, 6 3s are 18 and 6 4s are 24. Repeat the same. Now circle the first column, second column and the third column. So here we have the multiples of 9. Now let me explain seventh table. So write 1, 2, 3 in the given order. Now add whole numbers 0, 1, 2. So in which number you end, start with the same number. So 2, 3, 4, 4, 5, 6, and now add 70. So this is 7th table. Now let me explain 8th table. Write the even numbers in this order.
Good morning to everyone. On this auspicious day, let me discuss about why we are learning mathematics. Some people look cat or frog more beautiful. Nature is masterpiece. I want to understand that more deeply. This way lies the life sciences. Biology, for example. Other people, they pick up an example like a rolling boiling sun, like a star, and they think to themselves, that's fascinating. I want to understand that better. This is physics. Other people see an airplane, they want to build it, optimize its flight performance, build machines to explore all the universe. This is engineering. And there is another group of people that rather than try to pick up particular examples, they study ideas and truth at its source. They are mathematicians. When we look deeply at nature and really they try to understand it, this is science. And of course, the scientific method. Now, one way to divide the science is this way. You have natural sciences, that's physics, chemistry, life sciences, earth science, space science. You have social sciences. There you will find things like politics and economics. There is engineering and technology. There you will find all the engineering fields like biomedical, chemical, computer, electrical, electronics, mechanical. And all the applications of technology like biotechnology, communication, information technology, infrastructure. And all of that, at last, but not the least, is the humanities. There you will find things like philosophy, art and the music. Now, math does show up in all of these disciplines. In some like physics and engineering, its role is quite pronounced and obvious. While in others, like in art and music, the role of mathematics is definitely somewhat more specialized and usually secondary. Nevertheless, math is everywhere, and for that reason, math is especially good at making connections. How? How does math make connections? By examining some of the connections that mathematics can make through the laws of some mathematical ideas. Now, math is of course numbers, and perhaps the most famous number of all is the number pi. Pi was discovered because it represents a geometric property of a circle. It is a ratio of the circumference of every circle to its diameter. But nowhere in the world is anything a circle. Circle is a kind of pure mathematical idea. Around the year 212 BC, Archimedes was murdered by a Roman soldier. His dying words were, "Do not disturb my circles." His idea was surface area of the sphere equal to surface area of open cylinder that contained in it. That means one cylinder was taken and the exact sphere has taken which holds that sphere inside that cylinder. So surface area of the sphere equal to surface area of the container cylinder which contained in it. Around 1620, Johannes Kepler discovered a harmony of planetary motion. Isaac Newton would later build this work. Shown here is Kepler's third law of planetary motion. Next, from 1600 to 1700, Christian Huygens, Galileo Galilei and Isaac Newton were early pioneers studying the pendulum. Shown here is the formula. Period of the pendulum T equals approximately equal to 2 pi into square root of L by G, which tells us something about how long it takes to swing back and forth. The pendulum was hung here. How long it will take it will swing back and forth. The greatest mathematician of the 18th century, Euler, is responsible for discovering this formula. E power I theta equal to cos theta plus I sin theta. This formula provides a key connection between algebra, geometry and the trigonometry. In the special case where theta equal to pi, produces a relationship between 5 most important constants. In all of the mathematics, e power I pi plus 1 equal to 0. Some people have called this is the most beautiful formula in all of the mathematics. Euler, an engineer, gave this formula F equal to pi square EI by L square. Applied force. This is for applied force. Next one. The greatest mathematician of the 19th century, Gauss formula for standard normal distribution. A staggering amount of real-world data is distributed this way. Bell curve of the probability. Albert Einstein's famous theory of relativity, Einstein's field equation, R mu V is minus 1 by 2 into R g mu V plus A g mu V equal to 8 pi g by c power 4 T mu V. Now, with all this information, no exam, no question, please just relax. Look at all of these formulas. Every one of them with pi. Every one of this formula is having pi in it. This number that is born from the geometry of the circle. Look at this. All these related to different fields. Each and every one is related to different fields, but they have common connection to this geometric number from the circle. So, the circle plays a part in the derivation of these formulas. Now, circle is just one geometric form and math is so much more. And so, the world has the connection with math. Some people learn math as they are engineers. Some learn to develop their skills. Mathematics is like a vast ocean of ideas, and we took one cup. In our cup was one number, 5. One geometric form, a circle. And just look at the breathtaking scope of ideas that we are able to consider. The power of mathematics is that it is useful in so many different ways. This is the beauty of learning mathematics. This is the meaning by the words of Galileo. If I were again beginning my studies, I would follow the advice of Plato and start with mathematics. Thank you, my dear children, teachers and principal ma'am. I would like to thank everyone who have participated in this and contributes contents. Once for all, I would like to thank on behalf of Math Department to finish this program with great success. Thank you.